Welcome back to the Block Stretch Repair YouTube channel. Today we're going to be doing hopefully a short video on repairing this Mars Series 2000 dollar bill acceptor. This is for a somewhat local place. I've actually repaired this once in the past. I think it was 6 or 7 years ago I repaired it for them. And that ended up just being a simple capacitor in there, and I think it might be the same issue again. This thing is on 24/7, so it's probably been on this solid for those past 6-7 years. And I could have just had a cheap capacitor happen to fail on me. So we're going to open this thing up and see what's going on with it. I went ahead and grabbed a Mega Touch and everything to test this thing in, and I realized this cabinet has a much more accessible dollar bill acceptor, so we'll just splice into that one. It should be the same Mars Series 2000 120 volt dollar bill acceptor. You gotta be careful, some of these are 24 volts, some are 120, and I believe there's a couple other voltages, but I'm not 100% sure about that. But I was going to test this on my jukebox, but the jukebox has a 24 volt one, so I can't do that. Now, before you work on any kind of Mars Series 2000 dollar bill acceptor, or really any dollar bill acceptor, or really anything, check the voltage input. As you can see, this is a 115 voltage AC, and that is exactly like the one that we're trying to repair. You have to be careful because you will find ones that look the exact same, except hopefully they still have a bright red 24 volt sticker, and if you look there, 24 volts AC. Now, if you plug a 120 volt one into 24 volts AC, I doubt it would do anything, but if you plug a 24 volt AC one into a 120 volt AC one, you're gonna do some damage. Plugging this one into the power that just perfectly turned this one on, we have no lights here on the back. It made absolutely no noises. It is acting 100% dead. So I think we need to dive a little deeper. Now, these dollar bill acceptors are fairly easy to disassemble. This front plate's already off of this one, but all we have to do really is lift this up right here, and we can pull this centerpiece out. I don't know if I can do this one-handed. That's how you pull that part out. And now we're down to this part here. We have to slide this top plate off now that this is unscrewed. Not actually sure if you need to unscrew this or not, but you will eventually. But I don't know if I can do this one-handed. There we go. And now we simply remove a couple screws. Now that I'm thinking about it, it might have only been 5 years ago that I did this. Honestly, I don't know. I was a kid back then. Let's see if I can get this board out of here. Let's hope none of these capacitors are charged. That'll hurt. That's the cap I replaced previously, and it's bad again. That is surprising. As you can see, it is swelled up there at the top, which means that capacitor has failed. Now, before I forget where everything goes, and in case you've forgotten where everything goes, the white and black one plugs in right here, and the red and orange one, the red and black one plugs in right here. They look like they could very easily be reversible. It looks like we also have a nick in this wire. We'll repair that. I don't know if that's something I did. Again, this would have been done 5 years ago, and I was a kid back then, and I did not know how to work on stuff. So that very possibly could have been me. Interestingly, this cap has a dent in the top. I vaguely remember that actually being there when I repaired this previously, and I thought it was weird. I think we're going to go ahead and replace both these electrolytic caps. That one should just be a filter cap, so I doubt it's that bad because, well, I don't expect that to go bad. But we'll replace both these, and I'll go over this board and see what else I want to replace as just a preventative. After doing a little bit more research, originally this would have been a 35 volt cap, which means I actually already put in an overvoltage cap because this is a 50 volt cap now, which in most circumstances is fine. Going slightly higher voltage is fine. You can't go lower, but you can go slightly higher. However, it could have caused a slightly higher ESR, different stuff like that, and what I think actually probably is since the cap is slightly larger, it's closer to this voltage regulator. Voltage regulators put off a lot of heat, and this voltage regulator could have actually caused this to fail, because while capacitors, this one here, is rated for 105 degrees Celsius, at that runtime, they're usually only rated for about 1,000 hours or 3,000 hours. The higher the temperature that it's running at, the amount of hours that it's rated for drops drastically. So with this extra heat right here, this failing in 5 years could totally be expected. Now, I'd love to go through the schematics and actually take a deeper look at this, but unfortunately, they're not available. The company still makes these, and they still repair them, so I doubt they'd give them to me even if I asked. I didn't actually bother, but I doubt they'd actually give them to me. So, unfortunately, I have no schematics to look at to see if I can figure out the correct actual ratings for this cap, correct ESR and all that fun stuff, and if what else could be causing it. The MOSFETs and diodes here, I really didn't think are going to be causing it, so I decided to just not replace those, but I did buy a new voltage regulator because a slightly faulty voltage regulator could be causing more heat, so we're going to put in a brand new voltage regulator as well as the new cap. I also went ahead and ordered a new filter cap because this one has a giant dent in the top of it. Right here are the 3 components that we need to replace. We have our new cap here. It's a nice actual brand name. the correct rating and size and all the right voltages and all that. We have our voltage regulator right there. I'm not going to move that because it'll make my cap go rolling away. And our new filter cap, which I was going to get the same brand for filter cap, but they did not unfortunately sell one in the same dimensions. But I went with Chemicon, which is another very good brand name. So they should be good, and they're both 105 degrees Celsius rated caps, just like they would have been originally. Now we're going to use our desoldering gun here and just stick it over the legs of the caps, warm it up a little bit, and just suck all the solder out of there. We'll probably have to add some flux. While this is probably leaded solder, the rest of this is probably lead-free solder, and a little bit of flux will go a long way in helping this lead-free solder melt. Now we're going to be using leaded solder to solder this stuff in. A lot of people like to claim that lead-free solder is just as good, and they're wrong. I can solder with lead-free solder all day. I do it all the time, but leaded solder is simply better. It is stronger. There is a reason that the government has military exemptions for leaded solder. Government contractors can use leaded solder for military applications, from my understanding. So, leaded solder is what we're going to go with. It is simply better. That right there is the original voltage regulator. It is a 7808 CT, and we're going to be replacing it with a 7808 CT. For some reason, you're somebody that complains about me shotgunning parts at this. If you can't tell, the top of this cap is bulged out, so that's how I obviously knew it was bad. But let's just take a measurement of it and see how bad it really was. Now remember, this is a 470 microfarad cap, and 1.5, 1.4, 1.6. Oh yeah, okay, so yeah, it is 160 to 150 to 140, depending on where it decides to rest at, which is obviously bad for a 470 microfarad capacitor. Plus, once you actually were to apply voltage for this, I'm sure that would drastically change. This cap is definitely bad. And just like that, we are done. No giant dent on the cap. However, we're not actually done. There's a trace exposed right there beside this cap that I don't like. I scratched it too much with the soldering iron, I guess, right there, and scratched off the coating there, which means if somebody were to try and replace this cap in the future and they weren't paying attention, they could accidentally bridge this cap to that trace. So we're going to use a little bit of solder mask, that's the word I was looking for, to cover that up and make it so nobody accidentally solders to that. The green paste there on that razor blade is UV curable solder mask. We're going to take a little thing to dip into that and just put a little thin coating over that. We'll take a UV light and cure it, and then nothing will accidentally be soldered to it in the future. UV light a bit overkill? Most certainly is, but it'll do its job. And just like that, we don't have to worry about solder accidentally sticking to any of the spots that shouldn't have solder sticking to it. So let's reinstall this in the machine and see if it actually works. I almost forgot, there's a little bit of damage to the insulation on that wire, so we're going to fix that. We're going to depin this wire from this connector, run a piece of heat shrink over it, and shrink it down. Of course, the only heat shrink I had that was small enough is clear, but it's good enough. It's not coming off of there, so we're good. Let's put this wire back in the connector. And now, we can see if it works. Actually, the way that wire probably got nicked is it probably somehow made its way in there and got whacked by that arm, which is what homes that fancy dollar bill pushing plate. It wasn't probably routed correctly. Now we're gonna make sure it's all routed correctly. Now, without further ado, let's plug this into the machine, see if it functions. If it doesn't, well, then we'll have to fix that. If it does, there's a few more things we need to do to it yet. Plug this in, ignore that. We should hear we should hear the dollar bill acceptor cycle, that's good. Let's see if it'll take $1. Do believe it should have lights, though, there in the front, so we might still have an issue, actually. But let's just see if it'll take $1. And it does not take it whatsoever. Okay, so what we could have is a bad connection between this bottom section and the board. Let's pull it apart and see if that's the case. I might have just not plugged it in fully. I verified everything's plugged in. We're getting 2 blinks, which is disabled by machine, which is weird because when I plug the other dollar bill acceptor in, it's not disabled. So I'm wondering if I have something set wrong. I'm just going to do a little bit of quick troubleshooting and see what happens. I have been bamboozled. Those that know Mari's Series 2000 dollar bill acceptors are probably laughing right now. I apparently did not know Mari's Series 2000 dollar bill acceptors as well as I thought. AE. AE. VN. This is a vending machine dollar bill acceptor. It won't work on this arcade machine because it's not always on. I have to have a jumper in there that jumpers some pins that would turn this to always be on. That's why this is reporting that it's disabled by the machine, because it doesn't have any communication with the rest of the machine because it doesn't know if the machine has changed or anything, so it's disabled. That's why this isn't working, but it is actually working. Unfortunately, this does mean all the dollar bill acceptors I've been staving out of like mega touches are actually a little less useful than I thought, because I can't use them in vending machines. Ultimately, I can still use them in stuff like claw machines, and that's the big spot that I actually use them in is claw machines, because for some reason everyone pulls them out of claw machines. So whenever I go to resell a claw machine, I got to put a dollar bill acceptor in it if I want to get any real value, because those are actually still used in businesses. Arcade machines tend to not be. So it's still worth pulling them out, but they're not as useful as I thought. That chip right there is the program chip. Unfortunately, it's not something I can copy with my copying machine, and most likely, apparently they have a security feature that makes it, if they enable it, they can't be copied, and I have to imagine they enabled it. So, unfortunately, there's no copying those and cloning them. Since we know that it at least is most certainly probably working, now we need to do some maintenance. So I'm going to pop this tray back out. We're going to wipe all those sensors down with a little bit of soapy water, get all those cleaned, and then what we're going to actually do is take some fancy chemicals that I have and restore the rubber belts. We're just going to do a quick cleaning of that. Those rollers are real nice and dirty. Those rollers are looking much better. Now we need to actually have this cycle a couple times so I can fully clean all the way around this belt. And then we're going to apply a chemical to it. Super conveniently, the monitor on this machine just died. I swear every time I get this machine ready to sell and I just, have to just do a stress test on it before I actually list it for sale, something breaks. Last was the marquee light, and now the monitor's dead. Cool, I guess we'll have to figure that out. It's already been recapped, so who knows? That'll be fun to figure out. Maybe we just have a broken solder joint or something. I don't know. But what we're going to be using on the rubber is this 408 C rubber renew. This stuff I've used on everything from record turntable idlers, which is what I actually bought it for, and it works great for that, and rubber in my car, like random rubber trim in my car. It works great on that too. This just kind of rehydrates the rubber, makes it nice and rubbery again, gives you a little bit more life out of your old rubbers. So that's what I did. I put some of it on microfiber and just ran it through here while I ran the thing so it would cycle back and forth. Now we have slightly rubberier grips to hopefully grip the dollar bills better, get a little bit more life out of those belts before they have to be replaced. So with that, our dollar bill acceptor is done. It works. This monitor's back. It'll die in about 10 seconds and start doing that fun thing again. But at least, yep, at least the dollar bill acceptor is now finished. Hopefully this time, though, it doesn't come back in 5 or so years. I mean, that would be out of warranty for most people, but they didn't pay last time, and they're not going to pay this time. It's a non-profit. I'm not going to charge them for it. So, hopefully, at least it doesn't break on them. If you like what you saw and you want to see me fix this monitor next, or whatever I work on next, to be fair, please leave a like and subscribe. I'll see you next time.